be doing some review stuff too. So this is what we are going to be doing here. So we are going to switch from standard form into vertex form. So to do that, we first need to remember that vertex form and standard form are from last week. Why not? Okay, so you'll notice that the standard form is this, what we were working with on the homework, and then this is vertex form. What does this one look closer to, vertex form or standard form?
Standard.
Vertex form. Do you see it has the parenthesis and the square like vertex form does?
Yeah.
So we are going to be changing standard form into vertex form by using something called completing the square to make perfect square trinomials to make it look like that. So that's what we are going to be doing today. This is an EOC topic for sure, so just make sure we'll be doing this again later on with solving. So if you don't understand it 100% today, we will be hitting on it again. So how do we convert from standard form to vertex form? So first of all, this is standard form.
It is standard form.
So you are going to move the c value to the other side of the equation as y by using the inverse. So I'm subtracting c from both sides.
You are subtracting c from both sides.
So notice I just subtracted c from both sides there. So the first step is to move the constant to the other side of the equation. Once you have done that, you are going to take that and you are going to add a blank to both sides of the equation. The reason you are doing this is because you have to balance your equation. You're going to be adding something to both sides of the equation. So think of this as a teeter-totter or seesaw or whatever. Have you ever played on those at a park? If you guys weigh different amounts, you know one person will be higher and one person will be lower. But if you weigh the same, you are even. So these are currently weighing the same on both sides. If we add 5 pounds to one side, that's going to make the other side go up. So we have to add 5 pounds to the other side to keep it even.
And then they're going to die.
No. So that's what we are going to be doing here. So then you're going to complete the square by dividing the middle term in half and squaring it. So what you're going to take then is what we talked about here. We divided this middle term in half, right? You guys see that? That was negative 2. Negative 2 squared, or negative 2 times negative 2 was, isn't squaring it the same thing as multiplying it? So this is saying take the b term, divide it by 2, and square it. And you are going to put that answer in both of your blanks.
That's a lot of twos.
That should say bx, not bc.
Too many.
Is that what you were going to ask? Sorry.
Too many twos.
It's my goal. So when you square something...
It shouldn't be your goal.
Hold up.
I'm joking.
It's like so many letters.
So 11.
I didn't think I would ever have to say too many letters.
Okay, guys. When you square something, it will always be positive. That's why I have a positive sign there. So you're going to then rewrite the equation with the factored form of your perfect square trinomial and move the constant to the other side. So right now you have y minus c plus b over 2 squared. You are going to factor the other side, and we notice that it's going to be the same thing times the same thing, right?
C.
What was at this end term? Was it b over 2 squared, or was it just b over 2? So we will be putting b over 2 in these spots, which becomes the same thing times the same thing, which squares it.
What?
So, okay, so let's put numbers in this, right? Because right now these letters mean nothing to you. Is that right?
Then why have them?
Because that's what you're going to be doing.
I hate letters.
I know.
Stupid grammar.
Okay, when you are ready, switch to the next page so I can show you exactly how to do this with actual numbers.
Ever write it?
What's up? Sorry.
Who decided to add letters into numbers and math?
I don't actually know. I'd have to look. I learned it in college, but I can't remember anymore.
Well, you should know by now because everybody's going to be asking.
All right. Guys, that was super confusing with the letters, so let's go through those steps. The first step in completing the square, and just so you guys know, we are only doing this when A is 1. There is a way to complete the square when A is not 1, but please do not complete the square unless A is 1. Do you understand me? It's very much more challenging if we do it the other way, so we're not going there. You will do it in Algebra 2. So, do you see how A is 1? You see that? Don't be doing this all the time.
Why is there random squares?
Okay.
Yeah, there is.
I don't know.
We have 2 random stairs.
I have no clue.
Stairs.
Guys, please stop. So what is the first step?
Minus C.
Minus C. What is my C value in this case?
5.
So I'm going to subtract 5 on both sides. What did the next step say? You can always flip back and forth. What did the next step tell us to do?
Add blank.
Add blanks to both sides to keep our equation balanced. You're on the wrong problem, I think. I don't even know what you're doing. Come on. Okay. So we need to make a perfect square trinomial. A perfect square trinomial factors into the same thing times the same thing. So we know to do that, this has to be this divided by 2 squared, right? Didn't we learn that with this? This was divided by 2 squared, divided by 2 squared. Isn't that what we learned from my little bitty warm-up thing over here? So, negative 8 divided by 2 is?
Negative 4.
Negative 4. Negative 4 squared is?
Yeah.
So, in both blanks, to keep the equation balanced, we are going to put 16. That is going to help us make a perfect square trinomial that factors into the same thing times the same thing. That's why we're doing it. Now, why can you do this? I can do this because I'm adding the same thing to both sides, so it keeps my equation balanced. Yes? Because you're doing negative 4 times negative 4. 2 negatives make a positive. So, I combine my like terms, and I get y plus 11, and then I'm going to factor this side. Okay, what are you confused about? You never put the 16 up here. So this should have plus 16.
Yeah, but like I thought that was negative 4.
It's negative 4 squared. Because remember, so guys, why are we doing this? Think about it. It's the same thing plus the same thing to get to 8. 4 plus 4 gets you to 8, right? What do you do to get to the end term? You multiply it. 4 times 4 is? Do you see that way maybe a little bit better? So you add to get the middle term and multiply to get the end term. We don't have our end term, so we have to add the same thing plus the same thing. So negative 4, right? And then negative 4 times negative 4 is 16. So that's another way of looking at it. Okay? So how does this one factor? How does this one factor then? Kaylee?
Yeah, x minus 4, x minus 4.
Yeah, but
So let's think about this. If I were to distribute it, x times x is x squared. Negative 4x and negative 4x is negative 8x. Negative 4 times negative 4 is that the same thing times the same thing?
Sure.
Yeah, so we have y equals, sorry, not y equals, y plus 11 equals, can we rewrite that as x minus 4 squared?
Yep.
Doesn't that look more like our vertex form, which is y equals a times x minus h squared plus k?
Yeah.
What's the last thing to make it look exactly like that,
Plus
Alyssa? Subtract 11 so that the y is alone. Do you see that there?
Yeah.
Can you tell me what my vertex is on this real quick? What's my vertex on the standard form? What is it? 4, negative 11. Could I find my vertex using standard form and see if it's the same? Yeah, what do we use to do it in standard form? What? No, it's opposite, because remember, x minus h changes the sign. Yep. That's why I'm going over this again. So negative b, if we look back at the original, is 8 over 2 times 1, which is 4. What was our x coordinate of our vertex? Those matched. So then we substitute this back in to the original. I'm just showing you how it will be the same. So that's 16, negative 16. Did we get the same vertex? So do you see how those are the same? Notice too, their a values are the same. They both are an a value of 1. Do you guys see that?
Yeah.
So this is the exact same equation. If I gave this equation to Jana and Emma, one of them in standard form and one of them in vertex form, and I said graph these, they would come up with this exact same graph. Do you guys understand that? These are equivalent equations. All right, so that's the first one. The second one says, what if there is no C term? We don't have to subtract anything. We can just start by putting our blanks in. Thingamajig's, also known as blanks. So, another way to think of this. What plus what, the same number plus the same number adds to get 2. That's why 2 divided by 2 is 1. What? We multiply to get the n term. So if we have a 1 plus 1 here, 1 times 1 is, that's why we square it. And we put it in both blanks. Guys. Can we just stop, please? Stop. So the next step is to factor this part. Blaine, how does that part factor?
It would be, so y plus 1 equals parentheses x plus 1 parentheses x plus 1.
So notice you always want it to be the same thing times the same thing. If you can't get it to the same thing times the same thing, you've done something wrong. Do you guys understand that? So x times x is x squared.
Yes.
1x and 1x is 2x, and 1 times 1 is 1. Is that the same thing times the same thing? So we can rewrite that as it being squared. How do I make that look like vertex form? Okay, so what is my vertex, Cassie, of this one? Close. The negative one was correct the first time. You always do opposite h, comma k. That's why I'm going over this again, because you guys have forgotten probably because we've been doing standard form the last couple of days. So, opposite h, comma k, because h is negative in the equation and k is positive. So that's why. Now, if I were to do it from standard form, I would do x equals negative b over 2a. My b value is a positive 2, so that's negative 2 over 2 times 1, which is negative 1. Is my x coordinate of the vertex negative 1? Is that good?
Yep.
And then we check to see if we get the same thing here. And I get y equals negative 1 squared plus 2 times negative 1, which is negative 1. Did we get the same vertex?
Yeah.
Justin. I reviewed this today before your, going over your homework. That's literally what your quiz is going to be. 2 problems just like that.
2? Just 2? Oh, boy.
Okay, so you'll notice the vertex are the same and the a values are the same. These are equivalent equations. Okay, so let's put this into graphing so we can practice some more for your quiz. Let's do this to practice some more for your quiz. So this one we are going to start by graphing it in standard form, and we're going to see if it looks the same in vertex form when we convert it. Do we understand that? And I'll go back and forth a little bit. So the first thing you need to do here to graph it, I'm going to put this here. To graph it, what do we have to do if it's in standard form? What do we have to use?
X equals B over 2A.
So x equals negative b or opposite b over 2a. You have to know that by yourself tomorrow. So Emma, what goes in for my b then? Negative 2. Riley, what goes in for my a value?
X is
What is in front of it?
1.
So 1 does. So I have negative 2 over 2, which is negative 1. And then all we have to do is substitute that back in using your calculator. So go ahead and put that in your calculators real quick. If you don't know how to put it in a calculator, you need to figure that out today. Hey, you did something wrong.
I got 1.
Who got 25?
No, I I thought he said 20.
Oh, I was like, I need to talk to whoever you are. So it should be a vertex at negative 1, comma, 1. So then we just have to remember our pattern. If it's 1, we typically go. 2 is.
4,
3 is.
9,
What is the a value we're multiplying by?
Yes.
1. Okay, so we go out 1, up 1, out 2, up 4. And then up 9, out 3, up 9. Does anybody not know how to do the pattern? Because obviously you're going to have to be able to do that on your quiz tomorrow, so that's why I'm asking.
Oh, fart.
Are there questions there? All right, so let's just now see if we can complete the square. Is our a value 1?
yes.
So we can complete the square. So we are going to complete the square like we've been doing. That's what we did on the last page. When you're converting from standard form to vertex form, that's called completing the square. So I'm going to rewrite my problem here. And we're going to see if our vertex form equation matches our standard form equation. So what is the first step in completing the square, Clover? Switching from standard form to vertex form. Subtract that c value of 2. Brian, what do I do now? What? We will do that, but we first need to add our blanks. So then we're going to divide our middle term by? We're going to cut it in half because 1 plus 1 is 2. So that's why. So 2 divided by 2 is 1. And then what do we have to do with that 1? Not yet, because you have to square it first, because 1 times 1 is. So this just happens to be the same thing because it's 1. So yes, you do put the same thing in both blanks to balance that equation. So I have y minus 1. And we're going to go straight to the squaring of this. What should be inside of this?
X minus
plus 1.
It's x plus 1. We are trying to get a positive. So Mike, if you would have done minus here, minus 1 and minus 1 would get you a negative 2. Do you guys see that?
Yeah.
So that's why it's an addition sign. 1 times 1 is 1. 1 plus 1 is 2.
Okay.
So we have y. We add the 1 over. So we have y equals x plus 1 squared plus 1. Do we have the same vertex?
Yeah.
Yes, opposite h, k. It has an a value of 1, so we go out 1, up 1, out 2, up 4, like this one is? Okay. So do you guys see how that is working there? What is my transformation? What is my transformation, Alyssa? Go ahead. So it translates left 1, up 1. Does it reflect at all, guys?
9.
Is there a stretch or compress on this one? No. So there's no dilation. That's another name for a stretch and compress. So we don't have a stretch or compress, so it's no dilation.
So when your eyes dilate, can you just say my eyes are compressed?
For your eyes, when you dilate them, they stretch. They get, because your eyes are getting bigger.
So
Yeah.
in the quiz, we have to do all 3 of those, right?
If for this, since it's not all of them, if you just wrote that, that's fine.
Okay.
But if you miss these 2, if it does reflect or stretch, that's why I do it every single time to remind you guys to look for them just in case. Does that make sense? For you guys, you probably don't do that on your homework, but I just as a reminder during notes. Justin, what's my axis of symmetry?
X equals negative.
Good. And Connor? Stay awake. Justin Powers, what are my roots? They're imaginary or there's no real roots. Okay, we're going to do one more of these and we're going to look at a word problem. I don't know. I have to decide on that part, but was that one a positive one? So I definitely want to do the next one.
You do that.
I'm going to do the next one. Yes, I'm.
I have a question.
Yeah.
I don't understand whenever you take this and you're
So you're just basically saying the same number plus the same number to get 2 is 1 plus 1, right? So then you just have to multiply those to get the end term. So 1 times 1 is 1. That's another way of looking at it. So I try to teach it like almost both ways while I'm saying it, but sometimes you won't pick up on it. So just ask again if you get confused, okay? All right, guys. Jordan, what's my first step? I'm going to do this in vertex form. Let's just complete the square. Is A equal to 1, Jordan Fields? Is my A term equal to 1?
Yeah.
Jordan Fields.
Oh.
Yes. So that means we can complete the square. You can technically complete the square with other A values. I'm just not teaching it to you yet, okay? Okay. So, Jordan, what's the first step in completing the square? And you can look at your steps, guys. That's why they're in the notes. You are just learning this. If you need to look at those steps for every single problem tonight, they will get drilled into your head by the time you're done. Do you understand me? That's why they're there. Thank you. Jordan Coward, what's the next step? Look at your notes. Look on that first, note slide after the title slide. What do we have to add after the -4 and the -6x?
the blanks.
RC says the blanks. Okay, so you're going to have to help me find what goes in those blanks. So, what do we do with the -6? What do you divide it by? You divide by 2, which gets you -3. And -3 squared is? It's just positive 9, because negative and a negative is a positive. So, look at this with me here. Why are we doing this? Well, -3 plus -3 gets me -6. The same number plus the same number is -3 and -3. If I multiply those, -3 times -3, it gets me 9. So if this does not make sense to you, you can always think of it that way. Does that make sense? All right, so that's y plus 5 equals, and then it's going to be into something squared. Josh? -4 plus 9 is 5. No, that's a good question. I don't want you guys to not know where things came from. Josh, how is that going to be factored this time? It's going to be something similar to these. That's why I did this at the beginning with you guys. Do you guys see why I did this at the beginning? To get you guys used to it?
X plus 9.
It's not x plus 9. Because you have to multiply to get 9.
Would it be the 5?
3, and will our sign be positive or negative?
Yes.
We have to make a negative 6. So do you see how that middle sign determines what sign's there? Because negative 3 and negative 3 makes negative 6. Negative 3 times negative 3 is 9.
That's toxic.
Okay, so we then subtract the 5 over on both sides, and we have vertex form. What is my vertex in this one here?
3,
negative
5.
3.
Sorry, my bad. I didn't mean to say negative.
It is 3, negative 5, so we're good there. So 3, negative 5. Okay. And then to do our graphing, I'm just going to do 1, 2, 3. We typically go out 1,
Up 1,
out 2,
up 4,
out 3.
up 9.
What is our multiplier?
1.
So that's not going to change anything.
There's some smart ones. Easy, Ray. Easy.
That's just easy. Remember 1, 4, 9. That's the easy part. Totally easy.
Yep.
What is my y-intercept?
Yes.
There's 2 places you can look for it. Where's my y-intercept? Justin? 0, 4. You can either look for it on your graph or at the end of a standard form equation. Are my zeros at exact points?
No.
No, it's between what 2 values? 0 and 1 and?
5 and 6.
So that's 0, 1, 2, 3, 4, 5, and 6. Okay, before we do this, I want to check to make sure that we would get the same vertex if we used x equals negative b over 2a. So opposite of a negative 6 is a, and then our a value is 1. So that is 3. Did we get an a value of 3? Or an x value of 3?
Yeah.
Okay, if I substitute that in,
You substitute it in.
is that negative 5? Is that the same vertex? I'm just did it real quick, sorry.
Negative 5. It is.
It is the same. Because you guys could easily plug that into your calculator. That's why I did it so quick. So you guys see how these are the exact same equations. Vertex form, see, you can see the vertex. Standard form, you cannot see the vertex. You can see the a value in both of them are the same. Vertex form does not give you the y-intercept like standard form does. So there's certain things that are good about each form. Okay, let's go to that word problem. What? To graph it?
No, this one. On the word problem.
On the word problem.
On the quiz tomorrow, you need to graph from standard form because your a value is not going to be 1 all the time. And I have not taught you guys how to complete the square when a is not 1. Does everybody understand that?
Yes.
You will learn that in Algebra 2. So, I don't know what you were asking from here, so just 1 second here. So Joey tells his friend Tom that the vertex of the parabola is negative 3, 4. If the equation of the parabola is y equals x squared minus 6x plus 13, is Joey correct? So are you asking, could you find that from vertex form or standard form?
Doesn't matter.
Yeah, so I'm going to show you guys both ways, actually.
What?
So,
So fun, guys. So fun.
a is equal to 1, so can we complete the square?
Mamma mia.
Yeah.
Yes.
Yeah, so that means we can complete the square. So we could put this in vertex form to find the vertex. That's the first way we could do it. I want to do this just so you guys get a little bit more practice with completing the square since it's brand new. Okay. Connor and Josh, your heads should be up. What do you do first in completing the square?
You subtract the c.
So we subtract 13 on both sides. And then I'm just going to put the blanks in as I go there.
You are.
Whoa.
Who can tell me, actually no, Brian, can you tell me what would go in my blanks this time? which is negative 3. And negative 3, what do you have to do with that to get for the blank? Which is?
9.
It's positive 9. So 9 goes in the blanks. Very good. Very good, Brian. That's not an easy thing to remember. So negative 3 plus negative 3 gets us to negative 6, right? Negative 3 times negative 3 is 9. So I'm going to combine my like terms here. And then I got to factor that. Colin, how does that one factor?
Okay, so that one's going to be
What goes first no matter what? Let's get that done. What goes in the front?
I have
The x.
X.
Okay, so what is going to be at the end of that then? What times what gets you to 9? The same number times the same number. 3. And what will our sign be? What is our sign here?
Negative.
Because we have to do negative 3 plus negative 3 to get to negative 6. Negative 3 times negative 3 is 9. Guys, if you don't understand how to do this, please let me know now. Because you have to do this on your own tonight. Are we doing a little bit better as we've seen more examples? Better than all those variables on that very first slide? So we got x minus 3 squared plus 4. Is that the same vertex? Is it negative 3, 4? No, it is 3, comma 4. He forgot to switch h, right? What did you do? Poor Tom. Yeah.
I like those shoes.
Thanks.
Pretty tough.
Thanks. Okay, how could you have done this? Kaylee, you had said something else. What could you have done? Yeah, you could have just used x equals negative b over 2a. So that means that opposite of a negative 6 is a, and then our a value is 1. So that's 3. Can you already tell that he's wrong?
Yes.
Yeah, sure. Yeah, that's why. I got a different one.
What a silly thing.
But I think I typed it in my copy.
What?
It would be a different y because he got the wrong x.
I was going to say, I got negative 149.
Oh, maybe not. Then let me try this real quick. So y equals 3 squared. Yeah, I think you're wrong. 1 second.
I think I typed it.
Let me just do this real quick. 9 minus 18 plus 13. Negative 9 plus 13 is 4. So it should have been 4 still.